So today is 7-2. It says, understand the converse of the Pythagorean theorem. That is a big mathy way of saying that we're going to use the Pythagorean theorem to prove whether or not something's a right triangle. So yesterday, you were told it was a right triangle. You were given two sides. You had to find the missing side using the Pythagorean theorem. Today, you're going to be given, like this example, you're going to be given all three sides, and you're going to use the Pythagorean theorem to say whether or not it is a right triangle or not. So we're still going to use the Pythagorean theorem, and this is just a little bit of review from yesterday. It's a squared plus b squared equals c squared. If you try to do this and you don't use the actual theorem, if you just start writing letters or numbers everywhere and trying to add and subtract stuff, that does not work. You have to put it in this form, okay? A squared, use a plus sign, then square b, use an equal sign, and then c squared, okay? So let's plug in what we know. We know that if this is a right triangle, obviously this is the right triangle. If it is a right triangle, that's the right angle. And we know that the longest side always has to be our C, right? So we know that this would be our C. So we would put the 5 there. The other two are our legs. So interchangeably, A and B. So we would say 3 squared plus 4 squared. Okay, we've set it up. We put the hypotenuse over on the right, which is where the C goes, or the hypotenuse goes. And now we're going to square 3, which is 9. We're going to square 4, which is 16. And then we're going to square 5, which is 25. And then we're going to add 9 plus 16, which is 25. And it equals c squared, which is 25. Does 25 equal 25? Yes. So yes, this is a right triangle. We just used the Pythagorean theorem to prove that this was a right triangle. Now, you don't have to do this part, okay? This is just to show you the difference. What if I draw a very similar triangle and I put 3, 4, 6? Okay, when I square 3, I get 9. When I square 14, I get 16. And when I square 36 or 6, I get 36. I'm jumping some steps here just to show you the difference. Okay, I squared 3. I squared 3, which means 3 times 3. I squared 4, which is 16. Now, when I add this up, I get 25 equals 36. Does 25 equal 36? No. So this is a no. This is not a right triangle. So you can prove yes or no just simply by plugging the right. You got to plug the right things in the right spot. You have to do A and B are your legs. You have to do your longest side is always your hypotenuse. So it has to go over on the right in the C spot. But as long as you have everything in the right place, you can use the Pythagorean theorem to prove whether or not a triangle is in fact a right triangle. Okay. All right. So flip to the next page. It says, the essential question, how can you determine whether a triangle is a right triangle? Well, the answer to that is we're going to use the Pythagorean theorem. We're going to test it. And remember yesterday in example 1, I said that whole example 1 was just the proof that the Pythagorean theorem works. And it was a whole lot of mathy stuff that you didn't really need to memorize or know. You just needed to know that it proved the Pythagorean theorem. Same thing here. All this example is telling you, here it is right here. Okay, the proof of the converse of the Pythagorean theorem. That is a big mathy way of saying right here. If a squared plus b squared equals c squared, then the triangle is a right triangle. So this right here is the very mathy way to say it. This right here is just kind of the everyday way to say it. Okay, we're going to use the Pythagorean theorem. And if it checks out, then it's a right triangle. If it doesn't, then it's not. So let's try this example. A triangle has side lengths 4 inches, 5 inches, and 7 inches. Is the triangle a right triangle? Well, first of all, we have to decide what is our C. Micah? 7, because it's the longest side. Between 4, 5, and 7, 7 is the biggest number. So we know that that has to be our C, right? And so that means that the other two are A and B. And it doesn't matter which one you call A and which one you call B. But we know that because they're the two shortest, we know that they're the two legs. So we put the legs on the left. That's actually a nice way to remember it. Legs go on the left. Just now thought of that when I said it. Okay, the legs go on the left. And we know that the hypotenuse is 7, and that's the C, and that always goes on the right. Okay, now this is where everybody's going to participate. Jace, tell me 4 squared. Aiden, tell me 5 squared. And Essie, tell me 7 squared. And then Caitlin, I'll have you add 4 and 5 squared together. So 16 for 4 squared. Aiden, what's 5 squared? 25, good. Essie, what's 7 squared? 49. And then Caitlin, if you would add 16 plus 25. 41. So we get 41 equals 49. So does a squared plus b squared equal c squared? No. So is it a right triangle? No. And that's lesson 7.2. It doesn't really get any harder than that. Yes. Yes, because I'm going to show you there's one thing in the equations that we haven't really seen yet. Well, we kind of have, but we haven't. And it's actually easier. You don't even need a calculator to do it, but I do want to do an example with you. All right. Explain the proof of the converse of Pythagorean theorem in your own words. Remember, that's just stating this. Okay. Just saying that if you can prove that a squared plus b squared equals c squared, then you've proved it's a right triangle. Okay. You don't have to write that. I just wanted to point that out again. All right. On this one, again, I'm just going to go over this very quickly. The main thing you need to remember is that your longest side is always your C. And so notice that they put the 25 over on the C. And then the legs go on the left. So the 2 legs here, square everything, and then test it. Does 625 equal 625? Yes, it does. So this is a right triangle. Okay, don't let it throw you when it's decimals. Okay, the side links they give you are 6, 4.5, and 3.75. These are the 2 smaller ones, so you know they're the legs. This is the bigger one, so you know it's the C, right? You know that's the C, so you know that it goes over here on the C side. And the 2 legs always go on the left. And even though they're decimals, don't overthink it. Still put them in your calculator. It's not 4.5 times 2. Be careful of that. I've seen that a lot today. It's 4.5 squared, which means 4.5 times 4.5. Okay. And then add them together. Again, just because they're decimals, don't overthink it. If they equal each other, then yes. If they don't, then no, it is not a right triangle. Yes. No. You don't want to round because you're trying to prove it. So you're saying this exact number has to equal this exact number. So don't round it. Good question, actually. Very good. Yes. When you're trying to prove it, you can't round it. All right. So let's try this one. This is the one I said is going to come up where it's going to be a little different than what you've seen. So everybody should have a pencil in their hand. I want you to do this one with me because you will have one like this on your homework, and I want you to know what you're doing. All right. A triangle has side lengths of 10 feet, the square root of 205 feet, which that really looks weird, but I'm going to show you how to still figure out what your hypotenuse is. And the other length is the square root of 105 feet. Okay. Now, the first thing we have to determine is which one is our hypotenuse. And I don't know about you, but in my head, I can't just say between 10, the square root of 205, and the square root of 105 right off the top of my head, which one is longer. So I'm going to go ahead and put it in my calculator. So I want everybody right now to put in their calculator the square root of 205 and tell me what it equals as a decimal. Yes, ma'am. You can, but I would rather go the other way and put the other ones as decimals. But yes, you could. Yes. Sure. Go ahead and tell me what you got. Okay. So 14.3. I'll just go ahead and round it to the 10th. Okay. Somebody else tell me what the square root of 105 is as a decimal. Corbin? Put under the radical, put 105 and try it again. I might not have heard your first 10.2. Okay, I just didn't hear the 10. I'm sorry. So we got 10.2. Now it's rounded, but that's okay. We're close enough that we can at least see what is our biggest one, right? So we've got a 10 foot, an almost about 14.3, and an about 10.2. Now can we definitively say which one is our hypotenuse? Which one? This one right here, the square root of 205, right? Now that we know the bigger ones, now that we know what's bigger, we're not going to use these. Okay, now those are gone. Those were just a tool to use to say which one is bigger. Now we're not going to use those rounded numbers because now we're trying to prove something, so we have to be exact. We can't use rounded. So I'm going to use the exact measurements, and I now know that the square root of 205 is my C, which means this is an A, whoops, this is an A, and this is a B. And it does not matter which one you call which, right? But 10 is an A, and the square root of 105 is my B. So now let's set it up. I'm going to go ahead and write Pythagorean Theorem again, just to have a basis here to show you what I'm doing. Remember what we're doing when we plug in is we're plugging the value of A in for A, B in for B, and C in for C, right? So if we plug the value for A in, we would plug in a 10, right? If we plug in the value for B and square that, it looks really weird, but let's plug this exact right as we see it. So we're going to put the square root of 105 in for B. And then we're going to do the same thing. We're going to plug exactly how we see it. We're going to plug C exactly how it's written. So square root of 205 in for C. It looks really weird, but these are actually a whole lot easier, and I'll show you why. First of all, let's square 10. What's 10 squared? 100. Okay. Now, this is really nice. If you remember from yesterday, I said that a square and a square root cancel each other out. Remember? A square and a square root cancel each other out. What happens to that 105? Just drops right out. You don't even need your calculator when you're squaring a square root. So it's actually kind of easier when a side length is given to you as a square root, because then when you square it, the number just drops out. So without any math at all, what can we say that C squared reduces to? 205, just drops right out. Now let's add up A and B squared. So 100 plus 105 is 205 equals, we already said this side is 205. So are these side lengths of a right triangle? Yes. And when it says explain, here's the beauty of it. Right here. That's your explanation. You don't have to write out any words. As long as you show the math, that is your explanation. Okay? All right, let's look at example 3. You've got triangle LPN, which is right here. It's this little one inside. And it wants to know if 3.5 is actually the right height for that side length. And we know that if it is, it should create a right triangle. So we test it. Again, you have to be mindful. Straight across from the right angle, this has to be your C. So that means that 3.7 is your C, which goes over in the C. And then the other two, by default, this is a leg and this is a leg. And they go on the left. And again, just with decimals, don't let it throw you. In your calculator, 1.3 times 1.3, and write it exactly as you see it. Don't round it. 3.5 times 3.5, write it as exactly as you see it. Don't round it. Add those two together, and then you're going to see whether or not it is a right triangle. And this one is not a right triangle because 13.94 doesn't equal 13.69. Okay. All right. So let's do this. Try it. Okay. We're trying to see if this red one is a right triangle. So again, I'm going to be mindful here. I'm going to go opposite what I think is my right angle, and I'm going to call that C, which means by default, this is my A and this is my B, or vice versa. So if I square 17, that's squaring A, and I square 15, and I set that equal to, now I'm going to square, and I'm going to write it just as it was. So the square root of 514, and I'm going to square that. Okay, let's see. Jacob, would you square 17? Corbin, square 15, and Dalton, square the square root of 514. And then Micah, I'll have you add the two blue ones together when they're done. Okay. What is it? Try that again. 17 squared. What'd you get? 225. Good. Hang on. Jacob's got that one. 289. Okay, equals. Now, Micah, you're going to add those two blue. Dalton, tell me what I'm going to write on the right. Yeah, 514, because when we square a square root, 514 just drops out. Okay, Micah, what is 289 plus 225? What is it? You sure? 17 times 17 is 289. 289 plus 225. 514. So is the red triangle a right triangle? Yes. And as far as explain, that's what you did right here. So you're good. All right. Really quickly, flip to page 405. And this is where page 405 came in when I told you at the beginning of the hour to start there. That's why it was stuck in my head. I want to do number 12 with you because you have one like this on your homework. Okay. It says the side lengths of three triangles are shown. Which of the triangles are right triangles? Well, this is a three-part question. You have to test all three before you can answer yes or no on all three. So that means you're going to have to do 3 different problems to be able to answer this correctly. So let's color code this. We'll start with triangle number 1. And what triangle number 1 is asking is this side squared plus this side squared, does it equal the longest side squared? Okay, that's what it's asking. And 5/7 is bigger than 3/7. Think of a pie. Would you rather have 3 slices of the pie or 5 slices? You get more with 5 slices, right? So 5/7 is bigger. Now, this is a shortcut, and I'm going to show you why it works, and it's great. If your denominators are all the same, ignore them. And I'll show you why here in just a second. But you can ignore them. Okay, it's just a shortcut, but I'll show you why it works. Square 3 and you get 9. Square 4, you get 16. Equals square 5, you get 25. Add 9 plus 16, you get 25 equals 25. Is the blue one a right triangle? Yeah. Yes. All right. Now I'm going to show you why I was able to do that. If I don't do the shortcut, I also square the denominator. So I'd get over 49, over 49, over 49. My denominators are the same. So I would add 9 plus 16 and I would get 25 over 49. And this is 25 over 49. Is it still a right triangle? Yes. So adding those fractions, adding those denominators in didn't change a thing. You still get whether or not it is a true statement or not. Olivia?
Okay, so if like we're doing the same thing with fractions, would it be the denominator be different than the top, or will it always be the same? Like the denominator always be the same?
I believe on your homework they always are. If the denominators are not the same, then you've got a lot more work to do, because once you square everything, then you've got to get like denominators and before you can add them and subtract them. So I would say for every problem you're going to get like this, you're probably going to have like denominators. Okay, now again, this is a 3-part question, right? We have to see if number 2 is, so we are going to square 8, add it to square 8 and see if it equals the 15 squared. Well, 8 squared is 64 plus 8 squared is 64. 15 squared is 225. What's 64 plus 64? 128. So is the purple one a right triangle? Okay, now we got to do one more. And again, I'm going to say, because our denominators are the same, I'm going to take the shortcut. And I'm going to square 5, add it to square 12, and see if it equals the square of 13. So when I square 5, I get 25. When I square 12, I get 144. And when I square 13, I get 169. 25 plus 144 is 169. So is the green one a right triangle? So then when you go to answer your question, you would select that 1 and 3 are the right triangles. So when you have one like this, you really do have to do 3 problems worth of work to answer one problem. Okay. You'll have another one like this on your homework where it asks you about student 1, student 2, and student 3. They all say they have a right triangle. Which one is correct? You got to test student 1, student 2, and student 3. Okay. That is all I have for you. On your Savas, notice that it says on the screen, you'll see it here in a second when you pull it up, it does say use paper, because obviously you can see there's work to be done for every single one of them. So use paper. You need to have 6 problems shown on your paper. There's one that just says, is it a right triangle? Yes or no. Do I know that you can guess and get a 50-50 shot? Yes. But if you don't have that work on your paper, if you don't show your paper with 6 problems, then you're not getting credit. Remember, no work equals no credit. So make sure that you've got work paper. Make sure you label it 7-2 Math Excel and put your name on it. Number your problems 1 through 6. And especially the ones where you've got to do 3, make sure you're showing 3 different tests to prove whether or not they are all right triangles. Okay? And if those of you at home, if you have any questions, shoot me an email.